system design. So what is the principle of design here? You can say it like a good design have a more approaches. Not only we have to follow this, they has to have some certain options also to do it, and flexibility we have to be there. It should be structure. If it is structure, any changes it easy to do it. Design is not only the coding. Without design, I am telling you, is a high level of abstraction is also design, and it has to be a good quality and error free, and we have to divide the modules, divide and conquer, in the sense that we have to develop more subsystem in the system design. Here the example of the problem partition, like one problem or one model is there, we have to divide into more sub modules. After we have to integrate, it will integrate the problem. That is a divide and conquer method. So complex problems we have to divide in sub programs. Each and sub we have to handle independently, and whole we have to execute it. Abstraction is hiding the low level details is the abstraction. What is the levels of abstraction? Is the first data abstraction is to represent the objects, operations, all the things is the data abstractions. Car windows is object. What the car window we can open, close. These are the data abstractions. Command procedural abstraction. What are the function? It will reflect only the functional reference. Like starting the car. Yes, I can start. What are the things are background we involved is the steering, gear, engine. These all the things will be there. Only the starting the car, it represents only the function. What is happened? What is a control abstraction in the sense? Is a exact mechanism of a car brakes. Is a car brake is on control. It's a control to stop it or anything I have to. So one control mechanism. Car brakes, in the sense it will tell the mechanism what the car has to do it. So what is modularity? Modularity in the sense it have a instructions, it have a logic, it have a data, it have a functions. All the things will be there in each and every modules. So one model can invoke other. Of course, one model can be your insertion to the another model. Like here, one logic is I divide into more modularity to manage it very easy method. Here, first is a model decomposition. That is, I am dividing into a sub problem. This is the one. What is a composability in the sense? Already if we have any existing, we have the same module, if we are working the same project, the same model we can take it and we can enable it in the current project. And models has to be in the understandable manner. It has to be very easiest manner, and we have to be correct. We have to divide it. Unnecessary and without understanding, we not supposed to divide the model. So we have to understand each and every model, what are the things has to be happen, and what is the continuity. If any small changes, it's not supposed to affect the another models. In that case, we have to divide and we have to work it. Modular protection. Each model we have to protect like with the error free, and it has to be, the bugs has to be very minimum. Here two strategies we will follow. The one is top down strategy, bottom. Top down, the first highest we have to resolve, and later we have to come bottom, and step by step we have to do from the top to down. What is bottom up strategies? First finishing of the small modules, and by combining we have to finish the big modules. Yeah, what are the design process? Also the same, top level design and logical design they will follow, and we will do it. Design process, how we use the architectural design. What is architectural design? The framework, how the large systems are decomposed into a subsystem. So subsystem we have, which are the things we have to identify, and we have to finalize what is the link going to be happen in the subsystems, that we have to be explain the architectural design. Abstract specification, each subsystem what is going to be providing, what are things are going to do it, is the abstract. Interface design, each subsystem what are the interfaces are there, it is easy, has to be interact with the user. In that sense, interface has to be there. And next is the component design. What is component design? It has to be reusable. In later, if I have to use it in another projects, it has to be very easy to adapt it. Data structure, you know very well. Data structure algorithms, that it has to be get designed, and which model is going to be implemented. The data structures, all we have to do the planning. Algorithm, which algorithm has to be effective, stepwise manner we have to adapt it. Yeah, design strategies. What are the design? Functional designs and object oriented. Functional designs in a sense. Here one mathematic function in a sense. What are the things? Where are the places? This mathematical function toolkit is going to be Same if we are using, for example, if we are using square root, the square root function, in which places we are going to use it, we have to think it. So build mathematical functions, trigonometry functions, in build a symbol table, all the mathematical toolkit is going to be help me. So here we have to, so like this we have to functionally we have to design. So this function is there, in which are the places is going to get used, and from this going to be the output where it is going to be generated. All the things we have to get follow. Then object oriented design. Here if you have a card, what are things they have? It have three types. What are the attributes, what are the function it has, that all the things we have to mention in the OOPS concept, like object oriented design. And what is the design quality? It has to be efficient, and it has to be very flexible. It has to be like have the adaptability, robustness, clarity, all has to be come under